ladies and gentlemen, today's topic is markups and markdowns. We've been doing some basic percent work using the percent proportion, and we're going to be using that again today. So we're going to solve markup and markdown problems using percent equations. That's something new. It's something I haven't taught you, but I think you'll be able to catch on to it pretty quickly. Or the percent proportion. This is what you are used to using. It's what you've used before. Make sure you put the date and the page number. It should be December 3rd, and the page number is 73. And if you need to pause the video before we continue, please do so. All right, so first, before we can actually get into how we solve these problems, we have to establish what a markup and a markdown is. So please write this entire definition in your notebook. A markup is an increase in price. Up, increase, by a certain percentage. For example, a store is going to mark up the price of merchandise when they sell it to you so they can make a profit. They might buy the t-shirts that you want to purchase. They might get them for $2 a shirt and then sell them to you for $12 a shirt. That's because they need to cover their operating expenses and they want to make a profit. They want to make money. Please write down the definition here and the example, okay? Once you've done that on the other side of the page, let's go ahead and talk about markdowns. Markdowns are similar, except in this case, it is a decrease in price by a certain percentage. And when on earth would a company want to do this? Maybe they're not having the greatest sales. They might want to sell their merchandise at a discount to encourage people to come into their store and buy something. So we're going to be looking at markups using a percentage and markdowns using a percentage. Pardon me. All right. Let's go ahead and look at our first example. This can go ahead and go on the next page, which is page 74, December 3rd. And please write the problem at the top of the page. And I want you to divide the page in two with this line going down the middle. And on the left-hand side, write percent proportion. And on the right-hand side, put percent equation. We're going to solve this both ways. So a store purchases t-shirts to sell for $3 a shirt. They mark the shirt up by 70% in order to make a profit. What is the new selling price? So we want to know how much they're actually charging for a shirt that costs them $3. So let's talk about a proportion. And the way we're going to solve this question is we're going to find out how much extra, how many more dollars the store charges you. And then we're going to add that on to the original cost. So if we set up a proportion, this percent proportion, remember, is of percent 100. Our denominator of the second fraction is always 100. The percent in this case is 70% from our problem right here. And now we have to find the is and the of. So we need to find 70% here of $3 here. 70% of $3 will tell us how much they are marking up their merchandise. I will put a variable there, and then we go ahead and use cross products. Cross multiply to get 100x equals 3 times 70, which is 210. Divide both sides by 100 using our upside down t, and end up with x equals 2.1 if you were to do that division. So our markup in this case is $2.10. That's how much extra the store is charging you because they want to make a profit. So in order to figure out the final selling price, because that's what this problem is asking us to find right over here, the final selling price, we have to take the original price of the shirt, which is $3, and add to that $2.10. So our new cost of the shirt is $5.10. Make sure you wrote all that down. Take a minute to really try and understand it so we know what we're doing. And then let's go ahead and talk about how we would solve this same problem using a percent equation. Now, the basic percent equation is going to be something equals a certain percent of a number. Okay, what are you talking about, Mrs. O? In this case, for this example, the markup equals 70% of a number, in this case, $3. There's a couple different ways that I can use this equation. I can do it similar to the way I worked the percent proportion and say, okay, well, I need to find out what 70% of $3 is. And when you are using the percent equation, you turn your percent into a decimal. So instead of 70%, I would have 0.70. That represents 70%. Of means multiplication, and then I've got my $3. If I were to plug that into a calculator, I would end up with $2.10, just like I did over here. And then I would add that to my original cost, or the cost of the t-shirt for the store, which is $3, plus $2.10, gives us the same answer of $5.10. But there's another way you can think about this problem that's really kind of neat. Instead of taking it in two steps, for example, calculating the cost of the markup and then adding it to your original price, you can think of it in a slightly different way. So instead of finding 70% of the cost and then adding it to the cost, why don't we find 170% of the cost for the store? By making this 170%, I am taking into account the initial cost of the shirt. That's like my whole, my 100%. And then I'm adding to that the 70% markup. So the customer is paying 100% of the cost of the shirt plus 70% of the cost of the shirt. That's where we get 170% of 3. Now all I have to do is turn my percent into a decimal. So this 170% becomes 1.70. Of is multiplication, and then I have my 3. And that is going to equal not the markup like I had there, but the total cost, because it has taken into account the cost of the shirt and the cost of the markup. When I plug this into a calculator, when I do 1.7 times 3, I end up with $5.10. The same number I ended up with doing it the slightly longer way. Let's look at another question, except instead of a markup, it's going to do a mark down question. You can do this on page 75. And we're talking about TVs. A company wishes to sell more TVs and so has a 36-inch TV go on sale for only $45. This is a discount of 55%. What was the original cost of the TV? All right, first thing to notice, this 36-inch measurement here does not matter. That is extra information put into the problem to confuse you. So once we realize that, we can go ahead and create our percent proportion. By the way, I don't know if I mentioned this. You need to go on to page 75 for this problem. Set it up the same way that we set up page 74. Okay, so now we have is of percent 100, right? The percent we're dealing with is 55%, and we always have a 100 down here. And now we have to find out the is and the of. So $45 is the cost of the TV now after the discount. That's a discount of 55%. We want to find out the dollar cost of what that discount is. 1 second. We run into a little bit of a problem here, though, because the information they give us, this $45, is not the original price, and it's not the discounted price, guys. $45, or it's not the amount of the discount, sorry. It is the discounted price after I subtract the discount. Am I confusing you yet? I can get a little crazy here. So I have the original cost, which is what should go in this of category, and then I subtract my discount, how many dollars I'm taking off, and that's going to equal my sale price. I know that my sale price is $45, but I don't know the original cost, and I don't know the discount dollar amount, do I? I just know that it's a 55% discount. This makes setting up the proportion a little bit tricky, but watch what I can do. If the discount is 55%, you are actually only paying 45% of the cost of the TV. How do I know that? Because 100% is the cost of the full TV minus 55%, which is the cost of the discount. And that's going to give me 45%, which is the sale price. So what I can do here is, instead of having 55%, I can put 45%, and that tells me the sale price of $45. And what I need to know is the original cost of the TV, which would be X here. And something I hope you notice, see how the numerators of both of these fractions are the same? Well, then the denominator must be the same too, okay? So the cost of the TV originally is $100. And when we took a discount of 55%, we end up only paying $45. Now, that was really confusing with the percent proportion, wasn't it? Let's look at the percent equation for this. I am looking for the original cost of the TV. That is my unknown, so I'm going to call that X. And what is happening to X? I am subtracting 55% of X. So X minus 55% of X, because X is the original price, 55% is my discount, and it's going to equal $45. Okay, well, let's translate that into some math we can actually do something with. Let's take this part, 55% of X, and rewrite that. 55% is going to be 0.55. Of is multiplication, and X. We can just put 0.55X. Bring down the 45, and then we have this right here. Let's go back to combining like terms. Remember how I've told you over and over again, mathematicians are lazy? And there's a 1 right there in front of that X. So if I were to combine these like terms, and I know they're like terms because they have the exact same variable, I would simply subtract my coefficients. So I would do 1 minus 0.55. 1 minus 0.55, which leaves me with 0.45x equals 45. Notice that 0.45x is essentially 45% of the original cost of the TV. So now, here, let me just clean that up a little bit. 0.45x equals 45. How do I solve that equation? Using algebra. Upside down t. I need to get rid of everything attached to the x. So 0.45 and x are multiplying. I have to divide by 0.45. And I end up, if you put that in your calculator, 45 divided by 0.45 gives you 100. $100, the same answer as we got with the percent proportion, perhaps in a way that makes a little bit more sense to you, hopefully. We're going to be doing a lot of these problems tomorrow, but hopefully you understand at least the basics of this idea. And I want you to try answering this reflection question.
You can use either the percent proportion or the percent equation. It doesn't matter to me. And I apologize that this video is a little bit longer than normal, guys. I know. I'll keep it to 10 minutes next time, I promise. Bye-bye.